In this objective, we're going to look at 4.4 physical and chemical changes. The objective states explain the relationship between macroscopic characteristics and bond interactions for chemical processes and physical processes. So these processes that involve the breaking or formation of chemical bonds, we will call those intramolecular forces. So we talked about this in Unit 2. These typically are going to be classified as chemical processes because we are breaking and forming, we're breaking chemical bonds and forming new ones. So here the fact that we are making something new counts as a chemical process. Then when we're talking about intermolecular forces, so phase changes is what we talked about in Unit 3, these will be classified as physical processes. Sometimes physical processes can actually involve the breaking of chemical bonds. One of those could be when we talk about dissolving a salt in water. So this can either actually be a physical or chemical change because technically you are breaking the ionic bond when we're taking that solid and dissolving it in water. You do break the bond, but you could actually get that solid back if we evaporated the water. So there is kind of a thrown up in the chemistry world. Is it physical? Is it chemical? It's kind of a mixture of both. All right, so here we're going to actually talk about the skills for writing names and formulas. If you feel like you have a good grasp on naming, you don't need to watch the rest of this video. But if you need a kind of a quick breakdown on covalent and ionic, I will go over it right now. It's going to be fairly quick. If you feel like you need more background, I would go watch some of my honors chemistry videos on covalent naming and ionic. So again, we have three types of compounds. We have metallic, which consists of metals. We have covalent, which consists of nonmetals. And then we have ionic, which consists of metal plus nonmetal. So here, when we name, we're mostly just looking at covalent and ionic compounds. So here on the left, I'll talk about covalent naming, and on the right, I'll talk about ionic naming, okay? Make sure I definitely did not leave you enough space, so you may want to get another piece of paper before we start writing. If I have the notation X and Y, here when we do covalent naming, we're looking at two elements, but again, those subscripts, however we made it, like CO2, for example. So here, the first element listed is actually going to keep its name. Again, we are talking about covalent, so these are nonmetals only. So if your first one listed is carbon, you're going to leave it exactly as carbon. We also will be working with prefixes. So a prefix will go before the element's name. We will actually be using prefixes 2 through 10. And so here I'm actually going to change that line to look like this. Here to show you our prefixes, we're going to have 1 through 10. Make sure you leave yourself enough room to write all 10 numbers. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca. So those are our prefixes that we use for covalent. But when it comes to the first element listed, we only use prefixes 2 through 10. Now for the second element listed, things change a little bit. Here we actually drop the ending and add "ide." It kind of just depends on the element. So like oxygen will become oxide, nitrogen becomes nitride. They're overall not a lot of nonmetals. You just have to get familiar with them. Like sulfur becomes sulfide, fluorine becomes fluoride. You just kind of have to get used to it. This actually uses prefixes 1 through 10. Okay, we do have some exceptions, so we can leave that little area on the back. Exceptions is oxygen. Oxygen actually causes a lot of issues when it comes down to the prefixes, if you're using a prefix with oxygen and the prefix ends in A or O, you drop that letter. So for example, if you're looking at CO, I'll just write it right here, CO, you won't write carbon mono, hold on, I was actually doing it right. Instead of carbon monoxide, we'll drop that O on the mono and make it mon. So it becomes carbon monoxide. So here it would be carbon monoxide. Okay, so overall, based off those prefixes, the ones that oxygen doesn't change is di and tri, because those are I ending prefixes, but the O and A, you will drop that before adding it. Okay, and that's the quick rundown about covalent. Now let's talk about ionic. Okay, so for ionic, let's write the notation Ca. So when it comes to the first element listed, this is our cation, which will be generally a metal, but not always. But it's cations are positive. Here it keeps its name. I do want to note just real quick, do not use prefixes when it comes to ionic. We only use prefixes for covalent because here their charges aren't fixed or considered varied. So here we don't even use charges in covalent. So that's why we use prefixes. But with ionic, we have fixed and multivalent charges, so we don't need to use prefixes. Here, going based off that information, fixed charges, we don't need a Roman numeral. But if it's multivalent, like our transition metals, we do use Roman numerals. Roman numerals tell us the charge. So we use this for transition metals. Roman numeral tells us charge. Again, this tells us charge of the metal, okay? But again, we do have the fixed charges, like group 1 is +1, group 2 is +2, aluminum's +3 because it's in group 13, but then the rest of them, our transition metals and our post-transition metals, they can have multiple charges. Please note that we do have 3 transition metals that have fixed charges. That is silver. I should probably add this. Silver is Ag +1, zinc is 2 positive, and cadmium 2 positive. These are our 3 transition metals that have fixed charges. All right, moving on, let's talk about the anions. So anion negative, these are generally non-metals. I can't really think on the top of my head one that is a metal. Here, if it's monatomic, so mono means 1, we drop ending and add "ide." So like we did with covalent for the second one listed, we would do that too. So Cl- would be chloride instead of chlorine. And then we have polyatomics, which is more than 1. This is just straight memorization, people. Here, poly means many, so PO4 3-, this would be an example of a polyatomic. Here, you would just have to memorize, if you see PO4, has to be phosphate. So generally with our polyatomics, we have 8 and 8 endings. And if you're ever wondering, well, how am I supposed to know, the charge, and I just trying to like problem solve without knowing it, you would need to know the metals charge. The metals charge can always tell you. But again, I would encourage you to look back at my longer videos on ionic and covalent if you do have questions. But this is just a straight quick refresher for those that just needed something to help recap on what you had learned previously.